Wow, that last minute is the longest minute. Hey, everybody, welcome to Astronomy Daily Live. So it is 2 hours UTC, and it's time again for all of us to gather together as we do pretty much every single day and sit here and chit-chat for a while about all things astronomy. Astronomy has been a part of my life for its entirety, and that continues to this day. And I don't ever see it changing or diminishing in any way. It seems to be getting more and more intense as time goes by. So that's great. So this live stream is just about sharing a passion, and just having a little bit of fun. And instead of me, just sort of sitting here looking at things as I normally would be anyway, I am doing exactly that, but I am sharing it with all of you. So yeah. Welcome everybody. Come on in. This is sort of like a virtual porch where we just get together, sort of get comfortable on our lounge chairs, and we have our consumables of choice. This again is the hydrogen hydroxide tonight, the HOH. I find it a very soothing and comforting molecule, as opposed to dihydrogen monoxide (H2O), which is very energizing and keeps me awake. So yeah, I go with the HOH, the acid and base simultaneously. It's sort of like a coin, right, where it has a heads and a tails. Well, this amazing molecule is both an acid and a base. It makes the whole thing just like two faces of a coin. So yeah, I think it's a pretty amazing molecule. I never say too much about this, and it tastes really good too. So cheers. Hey there, Bobby. I sent you a link just like usual. So yeah, feel free to come on in. Watched a little bit of the final Mars Insight lander presentation. I watched a little bit of that today. Actually had to go out and do a rehearsal. So we're hey, the human, nice to see you there. This live stream is all about the science of astronomy. So welcome, come on in. We're just having a conversation here. I'm not necessarily in charge. I mean, this is my space, and I am king. But besides that, welcome. I was just talking about the Mars Insight mission, which is a lander. Well, at least at the moment, right now, it's a spacecraft. But tomorrow, at 20 hours UTC, it is going to be landing on the surface of Mars. And so, we've gotten pretty good at landing things on Mars and putting things into orbit over the past few years. So I'm expecting So I'm expecting there to be no real trouble at all. I mean, it's still going to be a nail biter, and everybody's going to be really excited. And I hope that the Marco spacecraft, those little CubeSats that are going along for the ride and are going to be actually providing uh, um, sort of a repeater service. The spacecraft is going to send signals to the Marco satellites, I guess, and the Marco satellites are going to transmit that back to Earth and back to the deep space network. So yeah, I think if you're talking about Eastern time in the United States, I believe that's 5 hours behind UTC. On this live stream, there is only one time, and that is coordinated universal time. So right now it is 2:06 UTC. Now, of course, we're presumably on a sphere. So, when it's noon where I am, meaning that the sun is directly on us on the north-south line, right? That's not where the sun is where you are, or where pretty much anywhere else. So we have to correct for that a little bit. And so I think Eastern time, it's 5 hours behind UTC. So if it's 20 hours UTC when this actually occurs, then for your local time, Eastern Standard Time, that'd be 5 hours less than that. So it'd be 15 hours UTC, or 15 hours Eastern Time, which is 3 o'clock in the afternoon. Hey there, Atta. Nice to see you in the chat. Welcome. Welcome back. So, yeah, just talking about Mars Insight a little bit. It's going to be landing tomorrow, somewhere around like 20 hours UTC. So I'm going to actually stay home and watch the whole thing. I'll probably tune into NASA TV. Those kinds of things I like to watch the actual source, right? So cool. Well, yeah, I hope your holidays so far are going well. Yeah, everything's good here. Like I was saying the other day, the holidays that I like are the ones that all of us, everyone, not just all the people, but everything, right? This mug, right, shares a lot of astronomical events that are sort of relevant and unique to the Earth, and that is the equinoxes. Okay, so NASA's saying 240. Okay, when I looked the other day, Uncle Bill, thank you, by the way. Last time I checked, which was a couple days ago, I noticed that it was at 20. So I'm going to go over to the let's go over there to the Mars Insight mission, and as soon as I load this here, I will share my screen. Hope everybody's doing well today. Everything's good here. So, okay. so I'm going to share my screen. So hide that. And if we go over here, it says, well, 17 hours and 43 minutes. That's a little hard. So let's do landing, the landing timeline. Okay, so Uncle Bill, this is sort of what I'm seeing, right? Is the landing November 26th, 12 p.m. Pacific Daylight Time. That's not right. You know, what is with these people? Come on. Really? Eastern Daylight Time? Are you serious? I think you folks can do a little better than that, can't you? We're not on daylight time anymore, right? We're on standard time. Yeah, I think that's a typo, but that's not supposed to happen. Okay, well, this is the info I have. Yeah. Oh, yeah. Atta, I definitely do not take them for granted at all. It's every single one is an absolute nail biter. So yeah, I mean those kinds of circumstances. I would say, you know, it's definitely not really even safe for me to be driving because it's like, that's a nervous time. But having said that, right, I'm thinking that that the landing is going to go pretty well. I think it's going to go pretty well. I think it's going to be uneventful.
Hey, Cockpit.
Hey, there's Bobby on the panel. Hey, what's going on?
Nothing much. So we spoke about the InSight lander.
Yeah, I just wanted to remind everybody one more time that that's going on. And yeah, if you haven't seen the preview, take a look at that. It's they did a pretty good job, and yeah, cool. All right. Well, so hope everybody's doing well out there in the universe and the world. Did the Europeans lose a lander just a couple of years ago? No, I don't. I think, yeah, I guess I'm gonna have to. I don't remember now. But yeah, you know, one of the, at least one of the parts of the presentation that I saw today was them pointing out that over half of the missions to Mars have failed, right? Over the years, more than half of them have failed. So, you know, that makes everybody a little nervous, right? But look, it has arrived, right? It is at Mars. I mean, it's basically at Mars, right? So nothing's gone wrong yet, right? So that's good. And I think, you know, they have propulsively landed on Mars, and they've actually done it for this spacecraft, because the uh, um, the Phoenix lander, which landed up north looking for ice. The Phoenix lander, I think that and InSight are basically the same spacecraft in terms of the structure, right? I mean, in terms of instrumentation, of course, it's totally different. But in terms of, what the thing looks like and how it basically operates, I think those are exactly the same. And Phoenix landed great, did a great job, did its thing, and done, right? Long gone. Well, I mean, it's there still, but yeah, just dead. So yeah, I don't have any reason to think that this landing tomorrow is going to be, I mean, other than a nail biter, yeah, I think it's going to be uneventful, right? We're going to get all the signals pretty much exactly when we're supposed to. So, the big deal, as he pointed out, one of the mission people, is getting those solar panels deployed. Okay, because if you don't have power, you're done, right? So yeah, you got to get those solar panels deployed. Make sure that you're seeing a voltage and a current, and then you're off and running. So yeah, and I think that's all going to go well. And they're going to have to wait for that, right? I think he said something like 5 hours or 6 hours or something like that. They have to wait because all these things are in a sequence, and I think the panels are deployed like 5 hours after landing. So yeah, they have to sit there and watch it go through all these steps. After landing, right? They have to wait for all the dust to settle. So they just have to sit there and do nothing. So yeah, there's a lot of, and that's how science goes. Everybody has this idea that science is this totally exciting, mind-blowing thing all the time. No, the process of science is tedious and laborious and painful, right? It's a painful process. You got to learn things, and you have to run all this data through, all of that. So yeah, right. Schiaparelli, okay. ExoMars, 2016. Okay. Yeah. ExoMars. Yeah. I forgot about that one. Okay. Yeah. So, I guess I can sort of qualify that with no serious offense to anyone else, but the record for NASA / JPL / who builds these? Lockheed Martin, I think. Lockheed Martin build those things. I don't remember. We've had a very good record, right? Very, very good record. So not too bad. I don't think has NASA lost any Mars spacecraft? Maybe early on. Don't remember. We several months ago we actually looked at the list of spacecraft that have gone to Mars, and I don't remember. seeing anything. By the way, hey there, Space TV. Nice to see you there in the chat. Yeah. The Beagle, yeah, that was lost. Yeah, like they were saying in that little presentation, that yeah, over half the Mars attempts have failed. So, but recently that percentage, right, has shifted. So it's a lot smaller now than what it was. Maybe I can say it that way. So, and yeah, I think that's a pretty accurate statement. So cheers. So yeah, I'll probably be watching that over on NASA TV. So I encourage you, if you've never witnessed a landing, a Martian landing, it's pretty cool. It's pretty cool. They oftentimes the commentary is a little, they're trying to fill up dead air, right? Because otherwise they're just waiting, right? So there's a lot of yakking, right? Good morning. But that's pretty easily ignored. Either turn the volume all the way down, or just ignore it. And actually, a lot of the stuff that they talk about is pretty interesting and pretty useful anyway. So yeah, I think they do a pretty good job with all of that. At least what I've seen in the past. But what I like to do, of course, is watch the control room, and watch the people, because they're like focused, right, on their monitors, right, and waiting for they're looking for something, right, and they're waiting for it, and they're waiting and waiting and waiting, and you can tell when things happen, and you don't have to hear any of their conversation at all. That things are happening, even if there isn't any commentary about it, right? So yeah, and a lot of times, they'll actually show the data, like up on the screen, like they'll be able to watch the Doppler shift, as InSight starts to hit the atmosphere of Mars. It'll start to slow down. Well, that change in speed results in a Doppler shift of the carrier frequency, that's communicating back to Earth, and the amount of shift is related to the change in velocity. So they can actually watch this thing coming in. They'll see it start to slow down. They'll see, the heat shield ejecting. They'll of course see, the parachutes deploy, and they'll see the landing, right? And that's what they're all waiting for, is the radio signal, the Doppler shift, to stop changing, right? Because when it stops changing, I think that's right, yeah. When it finally locks onto a frequency, right, that spacecraft has stopped, right? Stopped moving. So they'll know, and then I think right after that, it's supposed to send out, it's supposed to do sort of a systems check really, really quick. It's like, Am I all here, right? And send back a signal saying, I'm good. Now I'm going to go to sleep. Bye. Hey there, Andy Cowley. Nice to see you in the chat also. So yeah, all right. Well, cool. So yeah, I definitely encourage everyone to take a look at that. As I said, it's always really, really fun, just to watch the controllers, um, watching the data, uh, and the looks on their faces, just give it all away, right? So there's uh, real drama, for sure. If you're into reality TV, that's about as real as it gets, because for a lot of these people, right, they have been spending a substantial number of years working on this thing, right? I mean, they've they've got you know a lot of blood, sweat, and tears um, put into all this stuff, and that goes for the designers and the engineers and the people who bent the metal, and the people who tightened all the screws, and to all the instrumentation and everything else, right? It's a huge effort, and so yeah, I mean, it's a nail biter when you have to completely, right? You have to completely, 100% surrender, right? You have to completely let it go. I mean, in a certain sense, right? You have to say your goodbyes, right? Because that might be it, right? Um, uh, so that's why everybody's so happy, right? When they get a signal back saying, I'm okay, because it's like, okay, well, technically we've said our goodbyes because we're going to assume that it's going to fail. And when it doesn't, it's like, well, this is very cool, right? So, yeah, I don't foresee any trouble at all. Um, you know, they know exactly where they're landing, and it's in a. I mean, I don't think that I've looked at the landing spot. Not that it needs my approval, but I assume that it's a pretty almost boring place. Almost like Viking, right? They wanted to land Viking in a very, very, very gentle, nice place, and they did, So I think they're sort of doing the same thing on this one too. They're landing in a pretty easy spot, no big deal, and yeah, it should actually last for hopefully quite a while. So yeah, we'll see. We've got let's see, we've got it's 2:28 UTC right now, and the actual event is happening in like 17 and a half hours. Is that right? I think so. So 17 and a half hours to go until that happens. Hope you all saw the comet going around the sun. It looking at the pictures, it looks like it didn't make it all the way around. Should I? I can probably show that if you want. Just go over to Soho. Oh, and while we're over there, I can show you something else too. That just popped up. So let's go over to Soho here. We'll look at this comet that, like I said, didn't make it. He vaporized before he got all the way around the sun. But I wanted to point out in this image that look what we've got down here. We've got Jupiter, So yes, indeed, it is going to be close enough to the sun in order to see it. So remember, that Mercury is almost at inferior conjunction, right? He's in here somewhere. They've blocked out this part, and I wasn't sure if we were going to be able to see Jupiter or not, because I mean, it could have been, way down here or way up here, right? But nope, there it is. There it is. So this is about as far as Jupiter and the Earth get from one another, right? So Jupiter is on the other side of the sun, right? We're on our side of the sun, and then there's the sun. There it is. And then another approximately 800 million kilometers out is Jupiter. So the Earth's about 140 million kilometers, plus about 800 or so. So we're almost a billion kilometers away from Jupiter at this point. And yeah, don't try looking for it. It's way too close to the sun, right? The sun is about 1/2 of a degree in diameter. So there's 1 degree, there's 2, 3, 4, 5, 6, maybe 6 or 7 degrees from the sun. You're never going to see it. Never going to see it. The sun is going to have way too much glare. Now, the way that these guys can see it so close is because they've put a mask. It's called a coronagraph in front of the sun, and that's what this thing is. This is the apparatus that actually holds. It's probably a circular object of some sort. And then with software, what they've done is they've come in here and drawn this blue circle blue circle and white circle. The white circle is supposed to represent the position and size of the sun in the field of view, and then this blue circle is just there because the coronagraph does some really crazy optical things, and so basically the data inside of this circle is useless, right? The only thing really interesting is everything outside of that. And of course, it is incredibly interesting. All these rays, right, are shooting out from the sun. This is stuff being blown out by the sun. Presumably along some kind of magnetic force fields, right? And these are constantly changing, constantly. So, but yeah, it was a nice, pleasant surprise to see Jupiter coming in. So yeah, Jupiter's going to make its way this way, and when it gets exactly in line with the sun, that's when it's called conjunction. It's in conjunction with the sun, and that just means that they have the same right ascension. So, of course, the declination is different. So, let's go back to this one. So this is a wide field. This is a narrower field. And as you can see, here is Mercury up here now, right? So it's just sort of, and that image is being greatly distorted, right? So it's kind of messed up. But yeah, it's just sort of skimming the edge of this. So this is the same idea. It's just a narrower field of view. And most of these things that you see behind here are stars. There are some cosmic rays like that one. Maybe that one. But let's look at this comet that zoomed through. If you haven't seen this yet, then well, you're in for a treat. If you have seen it, you're in for a treat because you get to see it again. So this is just a GIF movie that is sort of slowly loading, and here comes Mercury right next to a star, pretty bright star. There's another star just moving in. So from down here will come the comet. There it comes. Now watch it go whoosh. And nothing appears. Yeah, it vaporized. So didn't see anything come out. So we'll let this run. It's got a little ways to go. Because it's taking its time loading. Here. Maybe it's mine. Machine's slowing down.
Anybody seeing Cosmic?
I hope you're still with me. Right.
You're on and off, Cosmic.
Yeah. Working on it.
Yeah, you're on and off, Cosmic.
Oh. Fixed. Hold on. We have to
nope, still on
these
and
things.
off. Yeah, you're off now. Definitely.
Drink some hydrogen.
Anybody check and still hear Cosmic? It's not my connection because his speed is down too for the YouTube window.
Our killer.
Okay, yeah, you're on and off, Cosmic.
Says in contact. I'm okay. Yeah.
Yeah, still on and off.
Well, coming back here.
Boom.
So, yeah. Okay. Well, that's totally my fault. Totally my fault. I'm trying to rectify. Dun, 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 dun. There we go. I think that might have made improvements. Yes? I think so.
It's all good.
I think so. Yeah, I have to yeah, I just have to not run these GIF movies. Oh, I've got the Hangout doesn't detect the camera connected to my computer. Really? Really? Okay, here, I'm going to disconnect.
Yeah, Cosmic's having a lot of technical difficulties.
All right, come on. Camera not detected. Uh-oh. Camera not detected. Ah, that's no good.
Oh, might have to reboot.
Might have to.
Yeah, you might want to cut the feed and go up ahead and reboot and redo it again.
Yeah. Oh, there we go. Yes. I cannot drop this mountain of viewers. No way. All right, well, cool. I I would like to show you the rest of that movie, but you saw the comet going through, and yeah, it was kind of neat. It was getting brighter and brighter and brighter, and then it started to fade. Right? It got like really faint, and then right at the end, it got really really bright, and then went behind the sun, and or at least behind that big round red thing, and you know if you look at all the images after that, I didn't see anything coming out the other side at all. So yeah, it either it's really hard to tell whether it's sort of shot right into the sun, or if it was coming around but it just vaporized instead. I mean, it gets pretty warm in those parts of the solar system. So yeah, vaporizing is really really easy, and they move so fast, right? I mean, they move so incredibly fast. I mean, millions and millions of kilometers every single day. Um, so yeah, pretty amazing, pretty amazing. So cheers to comets. When Soho was launched, and I think this is the story. They hadn't thought of being able to see comets, so I think it was sort of a very pleasant uh, surprise when they saw these comets, and it's like, wow, right? I mean, that is very very cool. So I think they've counted over 3,000 comets now, um, uh, in those years. What, it was launched in 95, right? So 95, that's 23 years. I've got the calculator, actual physical calculator. Always, every good scientist has a calculator within arm's reach, right? I mean, you saw that, right? I mean, it was over here. It's like I don't have to reach very far. Whoop, there it is. Anyway, so yeah, I don't remember. I don't remember how many there are. Shoot, we could probably find out, because I was just sort of interested in knowing what the average was every
How long
single
have you been
year.
having that calculator for?
I have had this calculator um, easily as long as Soho has been in orbit. Pretty easily. I want to say I got this in about 19.
Uh-oh. You froze. Yep, you definitely froze. Yep, you're frozen. Like Elsa just got you by the